Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on Current Initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Carmen Blackwood. She's a scientist at Jet Propulsion Laboratory in Pasadena, California. We're going to talk about global and regional oceans and climate interactions and feedbacks with, the behavior of the oceans. So, again, thank you, Carmen, for coming. How you doing?
Hi, Richard. Thank you so much for inviting me to talk with you today and share a little bit about my research.
Yeah, tell me a bit about your background, if you would first. How did you get involved and interested in climate and oceans, et cetera?
Right. So, hopefully that's an interesting story. Actually, as a student, so I grew up in Germany. I went to University of Bremen in Germany for my undergrad research. I started off in theoretical mathematics, so very much like topology, algebra. I thought that was all very interesting and that fascinated me a lot. But then when I came to the end, I really thought like, maybe something more practical related to the natural world would be interesting to pursue a career in. So that's how I started working as a research assistant and grad student at the Alfred Wegener Institute in Bremerhaven, studying physical oceanography and space geodesy. And that's how I first got started with my the type of research, and that's how I then also got connected to the work I'm doing right now. The work that I was doing in Germany already was connected to the satellite mission I'm still working on today, which is called the GRACE mission, the Gravity Recovery and Climate Experiment that measures the gravity field of the Earth. And so in my grad studies for my PhD, I was looking into how we can look at large-scale ocean currents from space using. So we're measuring the gravity field. So basically the attraction that Earth has on all bodies on the Earth. So basically what holds us on the ground here, but it also changes over time. The gravity field changes over time. And why is that? That is because Earth has a lot of water. And that water is moving around. It's, let's say, moving from the ice sheets. Ice sheets are melting and discarding their water into the ocean. So the ice sheets are getting lighter and the oceans are getting heavier. So using a satellite technique measuring the gravity field, we can actually tell how much that mass is redistributing on Earth.
Will this change the shape of the Earth? Will it change how it orbits? And I guess just the Now the different application of gravity and the different morphology of the field will probably change a lot of things, right?
Right, they do. I mean, the water mass changes themselves don't change what we call the static gravity field that much over time. But what we're really interested in is how it changes how we can observe changes in our water cycle in general, and what it means for things like sea level change, how, let's say, also the ocean stores heat. We can derive that from these measurements and things like that.
What kind of oscillations do tidal forces create, or is that a small portion of the entire?
That is a very good question, because that is a large contribution to the day-to-day changes that the gravity field experiences. So these are large fluctuations. So, but we of course measure them too. But what we're interested in are the longer term changes, let's say on a monthly basis. So what we're trying to do with the tides is using our knowledge of the tides to extract that signal out of the gravity field that we're measuring each day to derive the monthly changes that are then not necessarily related to the tides. But yeah, certainly the tides are a big part of those gravity field changes.
Well, how much does the gravity field change in the area of a particular part of coastline at lower high tide? Is it at all measurable, or is it tiny?
Well, let me try to give you some numbers here. So we're measuring changes that are quite small, and changes in the ocean, let's say, are about at a millimeter range of sea surface height changes. So that is, even at the coastlines where these changes might add up to a few millimeters or maybe tenth of millimeters, but that is how it would translate into a gravity field signal. So relatively small. It's not like we're changing the solid Earth a lot by these water changes.
What are the big changes, and what is causing discernible or large differences in the gravity field around Earth due to water movement? Right.
So in particular, I would say, what we can clearly see and measure and assess are the changes in the ice sheets. So we can see not only the seasonal changes in the ice sheets, but also how much water mass they're basically losing, where it's then going into the ocean. So those are some of the big signals we can see. And then in addition to that, more in general, we see on land the big hydrologic changes related to, let's say, rainy and dry seasons over the Amazon basin are very pronounced. So you can see a lot of seasonal signals. But then it's also interesting to look at the land hydrology, to look at droughts, for example. So while a lot of the satellite sensors that we have look at just surface properties on Earth, by using the measurement of gravity, we can actually figure out how much groundwater we're losing over time due to irrigation. Now, having said that, it's still, with these satellites, it's a relatively large area that we're looking at. So it's not like we can determine on a city level how much water there is being used, but it's more on the 300 kilometer radius type of a scale. But still, that informs us on a larger scale, let's say on the state and country scale, what is happening with the water resources and how we can plan things, for example.
What is the dynamic of water movement in the Arctic versus the Antarctic versus, areas that have a lot of glaciation that builds and melts, etc.?
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit FindingGeniusPodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit FindingGeniusPodcast.com and click Support Us today. Now back to the show.
What are some of the dynamics? So, well, we can talk about the thermal differences, maybe a little bit, Arctic versus Antarctic, the way the Earth is structured with having much of the continental mass in the northern hemisphere. We also see a lot of the thermal changes more in the Arctic. Some people call that the Arctic amplification of the global warming signal, where we see a lot more warming in the recent past versus a place like Antarctica, which is surrounded by an ocean that is actually surrounded by an ocean current that is connecting all of the world's ocean, called the Antarctic Circumpolar Current. And that current sort of makes also sure that Antarctica is a little bit more isolated from other areas in the Earth. And so the changes that we see in the Arctic they're related more to the atmospheric changes we see versus some of the melting and the mass changes we see in Antarctica are related to the ocean currents themselves changing and just bringing warm water to the ice shelf areas. So ice shelf areas are the floating parts of the ice in Antarctica, but also, small ice shelves in Greenland. So there we have basically the ocean bringing up warmer water to these ice shelves, which makes them melt more, which makes them thinner, and the ice is flowing from the center of Antarctica to these ice shelf in a slightly faster way. So we can see the mass loss that's then occurring by these ice shelves distributing the ice to the ocean.
Okay, well, are you seeing what you think are trends or patterns, or, what's going to be the consequence of further melting if that's happening?
Right. Yeah, we do see some trends happening both in Greenland and Antarctica. We see a decreasing ice mass, so more melting going on than in the past. Now, all of that is, of course, modulated by what we might call climate variability. For example, there's some natural cycles going on, especially if we're talking about the ocean. The Pacific Ocean has an oscillation called the El Niño Southern Oscillation, which is a big cycle in the climate system that happens on a period of about 2 to 3 years, where these changes in the circulation actually influence weather patterns, not only over the Pacific Ocean, but, for example, also impact us in California and broader scales around the globe, really, to the extent where we see some of these influences in the Arctic and Southern Ocean as well.
But have you identified what will happen? What's happening locally in the Arctic or the Antarctic, et cetera, and how is that reflecting on the climate that people experience, thousands of miles away?
Right. So that's an interesting field of study. It's not necessarily my research, but I'm part of a team that is organized by NASA called the NASA Sea Level Change Team. And people on that team are looking into how changes in Antarctica and these mass loss events or trends can influence coasts that are, thousands of miles away. So one effect that we can then measure and also make a point why anybody should maybe care about what's going on in Greenland and Antarctica is the fact that, so with the mass that the Antarctica and Greenland are losing locally or regionally. They're also, they're losing their mass, so they're also losing the gravitational attraction that the ocean experiences. So basically, the sea level that is closer to Antarctica, because Antarctica is losing mass, is actually lower, getting lower due to that. And then in the far field, what we call the far field, let's say for Antarctica, we in the US, we would be in the far field. So now with there, it would then increase because of the redistribution of the water in the ocean. There's actually some interesting tools out there that look at that effect and that people can play with so that they can see, like, well, I live in New York. What does the change locally look like when I look at a place like Greenland, and Greenland melts by this much, and how would that affect me in New York City? And then, by looking at some of the trends, I think you had someone on your podcast looking at climate models and models of ice sheets, and you can, feed all of that information and the physics into these ice sheet models, and then project into the future, let's say under a climate scenario similar to what we have now. Then you can project these changes into the future and see how it impacts people at the coast. So
if you like this podcast, please click the link in the description to subscribe and review us on iTunes.
What does that look like, though, diurnally and seasonally anyway? Someone's on a given coast. What will they experience, again, just naturally, diurnally and seasonally?
Well,
so that can be subtracted out of what may happen later.
Right. So diurnally and seasonally, right, it's the things that you naturally experience, like as you were mentioning earlier, the tidal fluctuations. That's something that you see on a diurnal basis. And then seasonal, you have maybe, hurricanes coming in. I think the most important point to make about sea level and the longer term trends of what we see, even though some of the contributions may seem small, like overall maybe like a foot or so. If you add a foot, still that adds to whatever your tides or storms are naturally doing. So I think that's the thing to consider on a more regional and local basis. So by the ongoing increases in sea level, that you have this background change that adds to whatever is happening on the diurnal basis in terms of the tides and storms and the flooding we experience.
So what is your observation? What do you think is going to happen according to the models you've seen over the next 10, 20, 50 years?
There's actually a recent report that has come out called from the IPCC, the Intergovernmental Panel for Climate Change. And so within that framework, scientists have developed some new projections that project changes up to a few tenths of centimeter changes over the next about 100 years globally, depending on whatever happens to our climate and however we, change whatever we're doing in terms of the carbon dioxide output. But still, even under conditions that are continuing as we do now or decreasing, that sea level will still change by several centimeters globally. That will continue for quite some time over the next 100 years or so.
Yeah, but what do you project? I'm not asking about IPCC and other people and scientists, quote unquote, whoever they are. You, with your models, what do you see?
What do I project? I don't know. I mean, I'm personally very interested in thinking about some of the more, nature-based climate solutions, looking into what types of positive changes we can make, and then go from there. So I wouldn't say I can, do a projection. Also, in particular, because my research is more connected to looking at observations rather than projecting. But for me personally, I think there's still a lot of potential to do things differently and have a positive outlook.
Okay, well, very good. What's the best way for people to find out more about your work? Where can they go?
So I do have a web page with JPL, and that is under science, science.jpl.nasa.gov/people/Boening. It's currently, that was my name just a few months ago, but you should be able to find me there under Carmen Blackwood too. So check out science.jpl.nasa.gov, and you can not only find out what I'm doing, what research I'm involved in, but also more broadly about the science we do at the Jet Propulsion Lab.
Very good. Well, thank you for coming on the podcast. I appreciate it.
Well, thanks for inviting me.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.